In this lecture, we are going to learn about the relational operator. So first of all, before we begin, let's try to understand the meaning of the word relation in English. The word relation will help us to establish the connection between two people or between two objects or between two different quantities. Similarly, in C programming, if you want to establish the connection between two quantities, let's say two numbers or let's say two characters, or if you would like to compare two different objects or two different variables, then you will have to use the relational operators. Now let's say I would like to establish the connection between two numbers 2 and 3. Okay, so let's see what all relational operators are available in C. So the first one is less than operator. So less than operator will help us to identify what is the relationship between the two operands of less than. The first operand here is 2 and the second operand here is 3. Remember, all the relational operators are the binary operators, so it will always have two operands. So in this case, I am trying to check if the number 2 is less than 3 or not. Similarly, I have less than equals to relational operator. Here let's write 2 less than equals to 3. So this will help us to establish if 2 is less than equal to 3 or not. Okay. Similarly, you have greater than symbol, a greater than operator, that is 2 greater than 3. So this is called as greater than, which will help us to identify if 2 is greater than 3 or not. Okay. Similarly, I have something called as greater than equals to, 2 greater than equals to. Okay. Now there is one important point to note. In C programming, we don't have this greater than equals to symbol or less than equals to symbol like we use in math. Therefore, we use less than equals to in place of this math operator and greater than equals to in place of this one. Okay. So this is nothing but greater than equals to. Now let's talk about the fifth one, that is equals to equals to. Let's say 2 equals to 3. This is called as equality. Now this operator equals to is not the same as the assignment equals to, right? If I write x equals to 3, 3 will be assigned to x. But if I write x equals to 3, this will check whether x is same as 3 or not, whether they are equal or not. If they are equal, the answer is true. Okay. Now for all these operators, if you can see, the output of these operators will be either in terms of true or false. Now the last one is not equals to. So if I write 2 not equals to 3, this will check for inequality. This will return the value true if 2 is really not equals to 3. Now let's see what would be the output for these expressions. So the first statement is 2 less than 3. Now 2 is actually less than 3. So therefore this will give us the value true as the output. Now 2 is less than equals to 3 is also true, isn't it? 2 is always less than equals to 3. So the output of this expression is also true. Similarly, is 2 greater than 3? No, 2 is not greater than 3, so the output is false. Now what about 2 greater than equals to 3? Is 2 greater than equals to 3? No, 2 is not greater than equals to 3, so this is again false. Similarly, 2 is equals to 3. 2 is not equals to 3, right? So 2 equals to 3 is false. This is not true, so this is false. And 2 is not equals to 3. Obviously, 2 is not equals to 3. 2 is 2 and 3 is 3, right? So again, this statement is true. Okay, 2 is not equals to 3 is true. Now this is the output for these expressions. Remember, relational operator, let's say this is a relational operator R. It will take two operands, let's say operand 1 and operand 2. Here let's say this is the operand 1, this is the operand 2. Relational operator here is greater than equals to. Okay, and the output will always be in terms of true or false. So always remember, the output of relational operator is true or false. Now in C programming, false is always represented by the integer number 0 and true is represented by any other non-zero value. Any non-zero value will represent true. So let's say -2 can represent true. Similarly, 3 can represent true. In most of the compilers, true would be represented by the integer number 1 and false would be represented by the integer number 0. But please note down that any non-zero value can also be treated as true. Okay, but most of the compilers will follow this notion that true is 1 and false is 0. Now let's write a program to demonstrate relational operators. So now let us write down a computer program to demonstrate the working of relational operators. So I've already created this program called as relational.c here. I've written down some comments. Let me come down here at line number 18. So this is example number 1, where you are supposed to write an expression to check if a number is negative. Now how do you check if a number is negative? We all know that a number is negative if it is less than 0. So here we are supposed to use less than operator. First of all, let me declare a variable x and let me take the input from the user for the variable x. Now we need to write down the expression to check if the number is negative. How do I know x is negative? It's very simple. If x is less than 0, then if this is true, x is negative. If this is false, x is positive. So the output of this relational less than operator, let me store this in a variable called as answer, and answer is an integer variable. Let me declare this here. Alright. So this expression at line number 23 would be true if x is negative, and it would be false if x is non-negative. We also know that in C programming, false will be represented by the value 0 and true will be represented by the value 1. Now let's try to print the answer. So the code is done. Let's try to compile this. Enter the x, so let me give -3. Answer is 1, that means -3 is negative. Let me try to give a positive number. Let's say 98. So answer is 0, that means 98 is not negative. That means 98 is actually non-negative number. So therefore the answer is 0. So this is how you use less than operator. Now let's solve this example number 2, wherein you are supposed to write an expression to check if the score scored by a student in mathematics out of 100, the score is y, is less than or equals to 30. Okay. So in that case, first of all, I have to declare the variable y, which will have my score. ANS will have my output of the relational operator. I enter the score here in line number 34 and 35. And now I need to write an expression here. What would be my answer is, now I'll write my expression here, that my expression is y, that my score should be less than or equals to 30. So I'm using less than equals to relational operator. The output of this is either true or false. If the score is less than or equals to 30, output is true, that is 1. If it is otherwise, the output is 0. Okay, let's try to see what is the output of this. So it is asking me to enter the score. Let me give the score as 29.4. 29.4 is less than or equals to 30, so it is true. Answer is 1. Let me give a value something like 43. 43 score is more than, it's greater than 30, so the answer is 0. It is false. It is not less than or equals to 30. Okay, so this is how you can use relational less than or equals to operator. Now let's talk about example number 3, wherein you are supposed to write a relational expression to check if the cash amount plus the bank account balance is more than $1,000. So in this case, first of all, I'll be needing a variable for storing the cash amount. So this is float cash balance. And one more variable for storing the bank balance. So this is bank balance. This is a floating point number. I'll be storing my answer in the variable answer of the relational operator. And I take the input of the cash and bank balance from the user. So here in line number 47, I need to write my expression. So I write answer equals to, so what is the relationship is the cash amount plus bank account balance. So I'll have to write cash balance plus bank balance should be more than, so I have to use greater than. So the sum of these two balances should be greater than $1,000. Okay, greater than 1,000. So that the output, the true or false value would be stored in the answer. Okay, and I print the answer. Let's try to test this program. So enter the cash balance. Let's say cash balance is $230 and bank balance is $780. So answer is 1 here, because if I add 230 and 780 together, I'll get more than $1,000. So if it is more than $1,000, I'll get 1. 1 means true. That means my total balance is greater than $1,000. Let me give one more input. $23 cash balance, $450 in bank. So answer is 0. That means my total balance is not greater than $1,000. Therefore, the answer is 0. Okay. So this is how greater than operator works. So example number 5 is a really interesting example. You are supposed to write an expression to check if the given number is even, right? So first of all, I'll declare a variable num, that is my number. I scan the number here at line number 77. So here at line number 79, I need to write an expression to check if the number is even. So how do I know if the number is even? It's very simple. I divide the number by 2. If the remainder is 0, that means my number is even. I already have my number as num. So I'll do num mod 2. That means I'm trying to find the remainder of number dividing by 2. If the remainder is equals to 0, that means I'm using equals to operator here, right? So I'm checking for equality. If this is 0, that means this is true. This statement would be true, right? If num mod 2 is 0, this statement would be true. So let's say if number is 6, right? So 6 mod 2 would be 0, because if you divide 6 by 2, the remainder is 0. So in that case, 0 is equals to 0 is a true statement. So the answer is true. That is, the value would be 1. So that value I'll be storing in the variable answer. So now let's try to compile this and see how it runs. So let me give the number 5. So answer is 0. That means 5 is not even. That means it is odd, right? So whenever it's even, the answer would be 1 because it is true. So if I give 12, answer is 1 because 12 is a even number. Why is the input 12 giving the answer 1? It's very simple. So first of all, it will be dividing 12 by 2 and it will find the remainder. If you divide 12 by 2, the remainder is 0. So 0 is equals to 0. This is a true statement. So true, that means 1. 1 will be stored in the variable answer. Therefore, answer is 1. So this is how it works. So this one is our last example. Example number 6. Write an expression to check if the character pressed from the keyboard is something other than the character capital X. Okay, so for that I'll be needing a variable called as ch. This is a character variable. I'll be taking the character variable as an input. Okay, now I need to check my character ch is other than X. So I have to use not equals to. I have to use not equals to operator. So I'll write ch is not equals to the character X. That means ch is not, this is as good as character ch is not equal to X. If this is the case, then the output is true, okay? Else the output is false. So the output of this entire thing I'll be storing in a variable called as answer. And let me try to display the answer. Sorry, the variable name here is ans. So let me try to run this. Let me enter the character y. So the answer is 1 because y is not equals to X. It is not X, so the answer is true. It is 1. So if I give anything apart from X, it will be 1. True. So T is also true. Now let me enter small x. Small x is not equals to capital X. So that is true. So therefore answer is 1. Okay. And if I give capital X, answer is false. Whenever you give capital X, answer would be false. For all other characters, answer would be true. Okay. So this is how not equals to works. Okay. So in this program, we have learned how to work with relational operators. I hope you have learned how to use relational operator and you should be able to now create a relational expression for the problem that's given to you. Okay. So that's all for this lecture. Stay tuned.